Alright, Chapter 3, sample test. Let's go through it here. For the function, determine the average rate of change from 3 to 5. So at 3, this function has a value. F of 3 is 7 minus 0.1 times 3 squared. So that's 7. This is 9 times 0.1 is 0.9. 7 minus 0.9 is 6.1. Then f of 5, so that would be 7 minus 0.1 times 5 squared. So that's 25 times 0.1 is 2.5. From 7 is 4.5. So the average, this is obviously going down, it's decreasing. So the average rate of change, it went down, let's see, we're basically going to be finding slope here. We're going to take 4.5 minus 6.1. That is something anyway. As x went from 3 to 5, so that's 5 minus 3. That went 2, and it went from 6.1, 5.1, 4.1, down 1.6. Yeah, 1.6, and so 1.6 divided by 2 is 0.8. That's the average rate of change. It went in the vertical direction, down 0.8 for every 1. So that's the average rate of change. Number 2. Find the intercepts, line of symmetry, or intervals of increasing and decreasing, and the vertex for each. So we have A is 3, B is -7, and C is -6, and the vertex would be at -b over 2a. So that would be the opposite of -7 is +7 over 2 times 3 is 6. So the vertex will be, that's one of the things we have to find, the vertex would be at 7, 6, and then we'd have to put that into the equation. So that'd be 3 times 7, 6 squared minus 7 times 7, 6 minus 6. That would turn out to be 4936 times 3 makes it 49/12 minus 49/6, and 49/12 is half of 49/6, so this would be twice as much. So we're going to end up with -49/12 minus 6. 49/12 is 4 and 1/12, so we got 10 and 1/12. -10 and 1/12. Alright, so now we got the vertex. So let's see what we have to do. Find the intercepts. That's a different thing here. The line of symmetry would be a vertical line, so it's an x equal, it goes through the vertex, which is at 7, 6. There's the line of symmetry. There's the vertex. Intervals of increasing or decreasing. This has a positive a, so this is a parabola, it goes this way. It's increasing from the vertex on, so increases from the vertex on, 7, 6 to infinity. It decreases from negative infinity, as is it coming down? 2, 7, 6. You see how important it is to get this first part right, so don't mess up the minus b over 2a. The opposite of b, if it's minus 7, it's plus 7 over 2 times a. Got to get the a, b, and c correct. Okay, so now we've got the intercepts. No, we haven't. We've got the line of symmetry, the intervals of increasing and decreasing, and the vertex. We just got to get the intercepts. So the intercepts are found by setting the y-intercept means x is 0. And so when x is 0, y would be, that would be 0, that would be 0, and you get minus 6. And if you set x equals 0, you've got a quadratic equation. 0 equals 3x squared minus 7x minus 6. It might factor, or you could just go straight to the quadratic formula. Let's see. I don't know that factors, so I'm going to go right to the quadratic formula. I was kind of looking at it a little bit. So that's the opposite of b, so that'd be 7. Quadratic formula is the opposite of b plus or minus the square root of b squared, so negative 7 times negative 7 is 49, plus a negative 4ac, so a times c is negative 18, times a negative 4 is going to be plus, I'll pull out my calculator, do 18 times 4, and I get 72, all over 2 times a, which is 6. And it's all over there. So I'm letting y be 0, and I'm getting, let's see, 49 plus 72, that would be 121, I believe. 49 plus 72 is 121. So this did factor, because the square root of 121 is 11, and that, if it comes out to be a perfect square under there, it means it does factor. But anyway, 7 plus 11 is 18 over 6 is 3, and 7 minus 11 is negative 4 over 6, negative 2/3. So there's the y-intercept and the x-intercepts. A lot to do there. Now this one, the vertex, you can read right off of it. The vertex would be, and this parabola is moved plus 3 and up 8. So there's the vertex. So the line of symmetry is going to be easy. It's going to be x equal 3. And then we have the intervals of increasing and decreasing. Now since this has got a negative and 2 in front of it, it's an upside down parabola. So it'll be increasing to the vertex and decreasing beyond. And we want to look at the x value when we talk about the intervals. So the increasing from negative infinity up to the 3 in the x, and decreasing from 3 to infinity. So there's the intervals of increasing and decreasing. We have the line of symmetry, we have the vertex. Now we have to find intercepts. If we let y be x be 0, to get the y-intercept, 0 minus 3 is negative 3. Negative 3 squared is 9, so we'd have negative 2 times 9 plus 8. So that's negative 18 plus 8 is negative 10. So that's the y-intercept. Now the x-intercepts, we put in 0 for the y, and we solve. And we don't have to do the quadratic formula now because this has x only in one place. We can just undo, we can solve this. We've got to get x by itself. It says subtract 3, square it, multiply by -2, add 8. Reversing that, we would subtract 8 from both sides. Divide both sides by -2. 4 equals x minus 3 squared. Take the square root of both sides and we would get x minus 3 would have to equal the square root of 4 is either 2, or x minus 3 would equal -2. Adding 3 to both sides, we get 5 when y is 0. And adding 3 to both sides, we get 1 when x is 0. Okay? So quite a bit to do there. I'll probably give you more room when I actually write the real test on this. Okay, 3. Find the points of intersection of these two, this parabola and this line. There's probably 2 places they intersect, and if you do this correctly, it should be pretty simple here. If you want to know when they intersect, the y heights have to be the same for the same x's. And so you set the y height, this x squared minus 7x, equal to the y height of the other one, minus 6x plus 2. And since we've got a squared, this is going to be a quadratic, so you set it equal to 0 to solve it. So I'll add 6x to both sides, and I get x squared minus, if I add 6x to here and to here, this is gone. This is minus 1x. If I subtract 2 from both sides, I get minus 2 equals 0. Here's my a, my b, and my c. And I could try factoring, or I could just use the quadratic formula. This one does factor pretty easily. The quadratic formula, I do the opposite of b. That'd be 1 plus or minus the square root of b squared. Minus 1 times minus 1 is 1. Plus -4 times a times c. A times c is -2 times -4 is 8. All over 2 times 1, which is 2. 1 plus 8 is 9. Square root of 9 is 3. So I got 1 plus 3, 4 over 2, or 2. And 1 minus 3, -2 over 2, which is -1. So those are the x values, but it says find the points. Now, by the way, this factors to x minus 2 and x plus 1. This would give us the minus 1, and this give us the plus 2. But it said find the points of intersection, not just the x values of the intersection. So I've got, it goes through the point 2 in the x, and both of these should be the same height if that's where they intersect. So I can put the 2 in either one of these and should get the same number. And that's a good way to check yourself on this one. If I put 2 in here, I get 4 minus 14, which is minus 10. If I put 2 in here, I get -12 plus 2 is -10. So they intersect at 2, -10. They also intersect at -1. -1 squared is 1. -7 times -1 is plus 7. So 1 plus 7 is 8. I should get 8 over here. -6 times -1 is plus 6. Plus 2 is 8. So there's the points of intersection. And you could graph these two and you can see them too. And there's a way to get you. You can go to the calculator and ask for those. Let me show you that also, just so you can see that there's another way to do this. If I type in x squared subtract 7x for one of them, the second one is -6x plus 2. If I push graph, let's see, it's not showing up there, so I'm going to go zoom 6. See if I can see the two intersections. There's the parabola, and there's the line. It looks like it hits about there, and they intersect again over here someplace. So this one's somewhere between -3 and 0. Between -3 and 0. So I'm going to go second, calculate the intersection between, yes, that equation and that equation. And my guess is about, -2. And it says -1, 8. Okay, there's one of my answers. The other one I think is out here somewhere near 2. So I'm going to go second, calculate, find the intersection between this equation. That's why it says first curve. Is that the one of them you want to use? And this one, is that the second curve? And I say yes, and my guess is about 2, and it says yes, 2, 10. -10 is the other intersection. Okay? 4. Don't let me trick you up here with this one. I wrote f of x equals 6x minus x squared. Let's write it in order. That's minus x squared plus 6x plus 7, so that the a is -1, b is 6, and c is 7. Don't let me trick you by rearranging it. Determine f of x if f of x has a maximum or minimum, and find that value. Well, since it's a -x squared, it's an upside down parabola, so it'll have a maximum. And the maximum will occur at the x value of minus b over 2a at the vertex. So the opposite of 6 is -6, over 2 times -1 is -2, so -6 over -2 is +3. At x equal 3, we will have the maximum. But I need to find that maximum, so I'm going to put 3 in here, so I get, and don't mess this up. This says square the 3 and then make it negative. So 3 squared is 9, so this is -9. 3 times 6 is +18. Notice they're double and opposite, and +7. So -9 plus 18 is +9, plus 7 is 16. So the maximum is 16, and it happens at x equal 3. Determine the line of symmetry. Well, that's pretty simple because it goes to the vertex. We found that it's at x equal 3. And C, find the vertex. Well, we just found out the vertex is at 3, 16. And the intervals where this function is decreasing. Well, if it's upside down, it's decreasing on this whole half. So starting for the x value at the vertex, which is 3, and on to infinity, this function decreases. Okay, that's page 1.